Hello and welcome once again to the Aakash BYJU'S JEE channel. My name is Atiullah and we are live with the Rankers Batch 2023. So if you want to be a ranker in JEE Main and Advanced 2023, then this is the place to be. Alright, so we are studying laws of motion and this is lecture 5 of laws of motion. Now in case you have not seen the previous lectures, you can always go to the Aakash BYJU'S JEE channel, search for the Rankers Physics playlist and you're going to find all the lectures over there. Alright, so on agenda today is Pseudo Force. Now, Pseudo Force is a very good mathematical tool, and if you are solving a question and you want to solve it from a non-inertial frame, you want to solve it from a frame which is not inertial, and we're going to talk about it, then it comes in very handy to solve questions better and faster. And in a competitive examination, whatever helps you solve questions quicker, faster and better, you should absolutely study that. Okay, you should have a good handle on it. So that is the objective of this session, to give you a good handle on Pseudo Force, and you will see that by using Pseudo Force, we can solve questions better. Okay, so we have people joining in. Ratnala is here, Nidhi is here, Dhruv is here. A very good afternoon to all of you. And if you are all set to get started with this session, quickly give me a thumbs up, quickly give me a yes, and then we will start rolling. Alright, all good? And remember that you should have your notebook and pen ready, because we are going to solve a lot of questions. You should make your own notes as well. That is also going to help you. Alright, so if everything is on point, we are ready. So just give me a thumbs up and we are ready to roll. Okay, so G. Mohammed is also here. Welcome G. Mohammed. Swastika is also here. So I think we are all set to get rolling. Alright. So let's talk about pseudo force. Pseudo means that it is not real. Okay, pseudo means it's not real. So if it is not real, why do we use pseudo force? Can anyone tell me? So I hope you have already heard of pseudo force. You might have used pseudo force. So I want to know from you, what is the objective of using pseudo force? Okay, Sapna is also here. Good afternoon, Sapna. How are you? Chalo. Why do we need to use pseudo force? What is the advantage of using pseudo force? Arpita is also here. Okay? To make our task easier. Okay, that's a very general statement you have given, Swastika. You need to be more specific. Okay, chalo. So you understand what is an inertial frame. You understand what is a non-inertial frame. Any frame which is accelerated with respect to an inertial frame is called a non-inertial frame. Okay, so constant velocity is not a problem, but acceleration is a problem. Okay, for example, that you are on Earth and you are watching a car going. Okay, now we consider Earth to be an inertial frame, and if the car is accelerating at some acceleration, then if you want to observe things from inside the car, if you want to become an observer which is going along with the car, then you are no longer in an inertial frame, you are in a non-inertial frame. And when you want to observe things from a non-inertial frame, pseudo force is a mathematical technique, or pseudo force is a mathematical tool that you need to apply in that frame in order to observe things correctly. Is that correct? Okay, gaming is saying, sir, confirm question on this topic. यार गेमिंग देखो, कंफर्म क्वेश्चन तो किसी भी टॉपिक से नहीं कह सकते हैं. सो वी नीड टू बी प्रिपेयर्ड विद ऑल द टॉपिक्स, राइट? ऐसा हम थोड़ी कह सकते हैं कि इस चैप्टर से क्वेश्चन आएगा ही आएगा. ऐसा तो कोई भी नहीं बोल सकता है. नोबडी कैन प्रिडिक्ट दैट. डू यू अंडरस्टैंड दैट? बट वी हैव टू बी रेडी विद ऑल द टॉपिक्स, राइट? चलो, अब मेरे को ये बताओ कि मैंने अपने एक्सप्लेनेशन में आपको बोला कि अर्थ इज अ इनर्शियल फ्रेम. इज दैट ट्रू? इज अर्थ एन इनर्शियल फ्रेम? Think about it and tell me. Okay, you already know that Earth is rotating about its axis, which means there is going to be a centripetal acceleration on anything which is at the surface of the Earth. You also know that the Earth is revolving around the Sun. Okay, so can we say that Earth is a inertial frame? Can we say that? So what is the thing here? Depends on how much precision we want. Yes, Swastika, that's absolutely right. Now, in objective sense, if we speak technically, no frame in the universe can be an inertial frame. Okay, everything is revolving around something. Okay, the moon is revolving around the earth is revolving around the sun is revolving around something. All the stars revolve around at the center of galaxy, you know that, or if you don't know, at almost all the galaxies that we have observed, there is a super massive black hole about which everything revolves, right? So everything is moving with respect to everything. So objectively, we cannot say that there is an inertial frame. But if we look at the accelerations that we are dealing with on the surface of the earth, what are the kind of accelerations we are dealing with? We are dealing with acceleration due to gravity, which is 10 meter per second square. We are dealing with accelerations with which a car goes. Now that is of the order of 10 or something. Is that correct? Okay. But the acceleration due to the rotation of the earth and the acceleration due to the revolution of the earth is much, much less than compared to the accelerations that we have to deal with on the surface of the earth. And hence, we say that earth is a good approximation of an inertial frame. In strict terms, it is not an inertial frame, but for all practical purposes, for all our calculation, earth is a good approximation of an inertial frame. Correct? Alright. Chalo, Rick Sundar is saying, is pseudo force a real force? No, Rick Sundar, pseudo force is not a real force. It is just an mathematical tool. It is a mathematical tool which we need to apply in order to observe things from a non-inertial frame. Okay, is that correct? Okay. Swastika is saying, I heard that earth moves with a massive speed, so its acceleration would also be high. Okay. Yes, it does move with a massive speed, but that does not mean its acceleration would be high. Don't confuse speed with acceleration. Okay, do not confuse speed with the acceleration. Okay, if you think about the centripetal acceleration due to its revolution, okay, what is the centripetal acceleration? It is v square divided by r. Now v obviously is very high, but r is also very high. Okay, so the average distance from the earth to the sun is 1 astronomical unit, and that's a very, very large number, very, very large distance. Okay, so what we can do is, because of these accelerations, we can neglect the acceleration and we can assume earth to be an inertial frame for all practical purposes. Okay, so anything, when we are observing things on the surface of the earth, anything which is accelerating with respect to the earth will be an non-inertial frame. Okay, would be a non-inertial frame. Is that correct? Okay, so everything which is attached to the earth, for example, this table, this room, okay, this water bottle that I have, okay, this camera that I have, all of these things are stationary with respect to the earth. So if I am observing things from this camera, okay, the camera is right front of me, and if we are observing things from this camera, then this camera is an inertial frame because it is at rest with respect to the earth. But whenever things move with an acceleration with respect to the earth, for example, you are riding a bike, you're driving a motorcycle, there's a rocket which is launched, all of those are going to be non-inertial frames. And we are going to see how this non-inertial frame is going to help us solve things faster and better. Okay, but first of all, how do we apply pseudo force? Okay, so everything depends on the frame of reference. Okay, so I'm going to move a little bit. I'm going to show you this diagram. Suppose this is an object. Suppose this is an elevator. Okay, let's assume this is an elevator, and you have put an object over here. Just a second, let me choose this pen. Yeah, okay, so you have put an object over here. Okay, now pseudo force is always going to act opposite to the acceleration of the frame of reference. By that we mean that whenever we want to apply, okay, we want to observe this block from a camera which is fit into this elevator. In that case, whatever we are observing, this is going to be a non-inertial frame. Is that correct? It is going to be from a non-inertial frame. Now, because of this non-inertial frame, we'll have to apply a pseudo force. And how do we apply a pseudo force? It is always going to be opposite to the acceleration of the reference frame. acceleration of the frame. Be very careful about it. We have the pseudo force has nothing to do with the actual acceleration of the object. It has nothing to do with the actual object you are observing. It has to do with the acceleration of the frame. So be very careful about it. Okay. So the pseudo force is applied always opposite to the acceleration of the frame. That is number one. What is the next thing? The magnitude of the pseudo force would be the mass of the object and the acceleration of the frame. Okay, do you get this? Mass of the object and acceleration of the frame. Is that correct? Yes, that is absolutely correct. Okay, so if I remove magnitude from here, then I can write that F pseudo is equal to minus mass of the object multiplied by acceleration of the frame. Is that correct? Okay. Hanuraj is saying, sorry sir, I'm late. No worries, Anuraj. We are just starting out. We have just started, so nothing to worry. You have not missed anything. Okay. Okay, so this is about the direction. What about the magnitude? The magnitude is also clear. Now be very careful that we have to apply all the real forces. Real forces को भूल नहीं जाना है pseudo force लगा के. So what are the real forces here? Mg is a real force here. Normal is a real force here. So we have to apply all the real forces. Over and above the real forces, we have to apply the pseudo force. Is that correct? Okay. This is how we deal with pseudo force. Also, when you have an extended body, okay, if you have a body which is rotating and translating, if you have a body which is an extended object, right now we are dealing with particle dynamics. We assume that the entire particle is just one particle. Okay. Now, when we deal with center of mass, when we deal with extended objects, when we deal with things which can both rotate and translate, in that case, what is the point of application of the pseudo force? It is at the center of mass of the body. So there, the point of application of the pseudo force is also going to be important. But right now, the point of application of the center of mass, the point of application of the pseudo force is not very important because we are dealing with particle dynamics. Okay. Another thing you should understand is that the pseudo force is not a real force. So it doesn't have an action reaction pair. Okay. It doesn't have an action reaction pair. It is just a mathematical technique. Okay. And of this we obviously know that it is applied for non-inertial frame of reference. Is this clear? Is the pseudo force concept absolutely clear? Obviously we're going to exemplify a lot. We're going to give you a lot of examples, but is the concept absolutely clear? If it is clear, quickly give me a thumbs up, and then we are going to look at a lot of different situations in which pseudo force Alright, we are back, guys. Am I visible? Am I audible? If yes, quickly give me a thumbs up and then we can continue. Sorry for the technical issue. It happens sometimes. Chalo, batao. Yeah, okay, alright, perfect. Swastika, you had a question. You can shoot your question. Meanwhile, let's look at this situation. Alright, Twinkle is also here. Good afternoon. Swastika is saying, if the lift is accelerating upwards, don't we observe that the normal reaction increases? Yes, absolutely, Swastika. So it is a common thing, okay, if you are in an elevator and the elevator just starts going up, okay, when it just starts going up, the acceleration is in the upward direction. So you feel heaviness, right? Do you feel some heaviness? You feel that you are being pushed down. Is that correct? You have that feeling. Why is that feeling there? Because of the normal reaction. Okay. How do we perceive weight? What does it mean to be? What does it mean? What does apparent weight mean? Okay. How do we perceive our weight? So Astika is asking, if the pseudo force is there, then can we also say that normal reaction will increase? Yes. So Astika, I'm going to show that to you. Be it a non-inertial frame or be it an inertial frame, we will see that the normal force increases. Okay, I'm going to show it to you in both the frames. Don't worry about it. Okay, correct. Sapna is absolutely right. When you come down from in an elevator, when you are in an elevator and it just starts going down means it is accelerating downwards. So you feel lighter. Yes, there is a feeling of weightlessness. Okay. Now when I am in an inertial frame, I am standing on this ground right here. Now this ground right here is not doing anything. Okay, it is not accelerating. So how do I perceive my weight? I perceive my weight by the force that is exerted by the ground on my feet. Is that correct? The ground is going to exert a force on my feet, and because of that I have a sense that this is my weight. That is how I perceive weight. If we change that normal force, okay, if we change that normal force, what is going to happen? The perceived weight is going to be different, and that is what is known as apparent weight. And any weighing machine that you use or any spring balance that you use is always going to show you the normal force that the machine is exerting on you, or the tension that the string is applying on you. Okay, so Swastika is saying, so it is also an action reaction pair. On the previous slide you wrote that there is no action reaction pair in a pseudo force. Okay, I'll explain that. If we work from a non-inertial frame, the acceleration of the frame is 0 and no force, pseudo force needed. Okay, so first I will answer Arpit. Okay, Arpit, when you are saying that the acceleration of the frame is 0, then it is no longer a non-inertial frame. Do you get this? As soon as the acceleration of the frame is 0, it is no longer a non-inertial frame, and hence pseudo force is not needed. So if there is no acceleration, we should not assume it to be a non-inertial frame. We should not have to assume it to be a non-inertial frame. It is again going to become an inertial frame. Okay, so obviously no pseudo force would be required. We will no longer call it a non-inertial frame. Okay, now I'm going to answer Swastika. Okay, so first what I'm going to do is I'm going to solve this from the ground frame. Okay, let's say I am on the ground and I'm observing this person. Okay, what are the forces acting? The forces acting would be mg on this first person, and there's going to be a normal force which is acting on the person upwards. What is this normal force? This normal force is the force applied by the weighing machine on this person. Is that correct? Okay. Now the lift is going with an acceleration of a upwards, which means the person is also going with an acceleration a upwards. So what will be my equation? My equation is going to be n minus mg is equal to m times a. Is that correct? N is in the direction of acceleration, so I'm going to take it as positive. Mg is opposite to the direction of acceleration, so I'm going to take it as negative. So the net force is equal to mass times acceleration. So what is n? N is equal to n mg plus a. So you see that the normal force has increased. That is why you feel that you are pushing the ground. Okay, that is why you feel that the ground is pushing you up more than usual. That is the apparent weight. So what is this weighing machine going to show us? The weighing machine is going to show us this reading, mg plus a. Is that correct? Okay. Now talking about the action reaction pair. Okay. Now let's talk about the action reaction pair, and for that what we are going to do is we are going to get into the frame of the elevator and use pseudo force to do it. Okay. Now I am in the frame of the elevator and you can see I am observing things from a camera. So what are the real forces? The real forces are mg downwards and normal force upwards. What are these? These are the real forces. Okay. Now I have to apply pseudo force. So what will be the pseudo force? Number one, the pseudo force is going to be downwards because the acceleration of the frame is upwards, and the pseudo force is going to be m into acceleration of the frame. Now when you observe it from the frame of the lift, what is the acceleration of this person? Can someone answer that? We are observing this man from the frame of the lift. Okay, I have a camera installed in the lift. I am looking at this man from the frame of the lift. What is the acceleration going to be? Obviously, it will feel that the person has no acceleration, which means that in this frame, the net force on the person is going to be what? It is going to be 0. And if the net force is going to be equal to 0, then we can say that N will be equal to mg plus ma, which is mg plus a. Is that correct? Okay. So you are going to get the same result if you are solving it from the ground frame or you are solving it from the elevator frame. You are going to obviously get the same result. Okay, perfect. Now let's talk about the action reaction pair. Okay, let's talk about the action reaction pair. Now Swastika, tell me that this normal force over here, what is the action reaction pair of this normal force? Can you tell me? And this question is thrown open to everyone. Okay, this force that the weighing machine is applying on the man. Okay, this weighing machine, the force that the weighing machine is applying on the man, what is the reaction of that? Okay, what is the reaction of that? What is the action reaction pair in this case? Can you tell me? Okay, can you tell me? Okay, so what I mean to say is, what is the reaction? Who is applying force on what? I'm not talking about the magnitude, guys. समझो इस बात को. Action reaction pair का मतलब क्या होता है? ठीक है, if one bodies apply a force on two, then two will also apply a force on one, and the forces are going to be equal and opposite. So in this case, what is this N? What is this N? Force applied by weighing machine on man. Is that correct? This is the force applied by the weighing machine on the man. What will be the reaction of this force? The normal force that the man is applying is on machine is the reaction force. Absolutely. So when you make the free body diagram of this weighing machine, then you are going to see that there is going to be a force N acting over here. Now this force is the force applied by the man on the weighing machine, and hence this is the reaction pair. This N over here, I'm going to mark it with a different color so that you can see that this N over here and this N over here are the action reaction pair. Is that correct? Okay. Swastika is saying gravity disappeared in this frame. No, why do you say that, Swastika? Why do you say that the gravity has disappeared from this frame? Obviously there is gravity. Why is there gravity? Because we are applying this force mg. Okay. This force mg we are applying in this frame also. Why? Because gravity is still present there. But in order to analyze the acceleration of the object from this non-inertial frame, we are adding a pseudo force. Okay, we are adding this pseudo force to give us the right answer in this frame. Okay, the gravity has not disappeared. The gravity is still there. Okay, the gravity is still acting, and the proof of that is that we are still applying a force mg on this man. Is that correct? ठीक है, तो action reaction pair क्या है? What is the action reaction pair? The normal force that the man is applying on the machine, ठीक है, this is the action. What is the reaction? The force that the man is applying on the weighing machine. That is the reaction. mg क्या है? mg is the action. What is mg? mg is the force applied by the earth on this man. So if you make a free body diagram of the earth, then the man is also applying a force mg on the earth. This is the reaction pair. But where is the reaction pair for ma? Okay, this pseudo force, this is the pseudo force. Where is the reaction force on this? Because no object is applying a force on this man, which is ma. No object is doing that. Okay, can you say which object or which thing is applying a force ma on this man? Can you tell me? Okay, there is none. There is none. Okay, because this is a pseudo force. This is just a mathematical adjustment. So we cannot say that there is going to be a reaction of this pseudo force, because reaction has to be on something, and there is no something on which I can apply the reaction force. Is that correct? So only real forces can have action and reaction pair. Pseudo force cannot have an action and reaction pair because it is not a real force. It is just a mathematical adjustment. Is that correct? Okay. So is this clear? Is this clear? Absolutely clear. So what we can say that is that the effective gravity changes. Okay. Can I say that? I can say that the effective gravity changes because what is the reading of the weighing machine? What is apparent weight? Apparent weight is the reading of the weighing machine, and you can see that the weighing machine is now showing more than usual, more than the correct value, and hence we call it the apparent weight. Okay, so in this situation we can say that the effective gravity, okay, be clear with this term, not the real gravity. Real gravity is always going to be G, but the effective gravity is going to become G plus A in this case. Do you agree? Okay, is this clear? Is this absolutely clear? Yes. Okay. And if you want to do this experiment, what you can do is you can take a water bottle. Okay, you can take a water bottle. Okay, this not this water bottle, but a plastic water bottle. Okay, you take a plastic water bottle and fill it with water and punch holes in this water. Okay, sorry, punch holes in this bottle. Okay, take a plastic bottle, fill it with water and punch holes in this bottle. So what you will see is that the water is spilling out, the water is flowing out, the water is going to come out from the hole. Okay. So when you keep it like this, the water is going to come out of the hole. But if you drop it, okay, if you drop it, what is going to happen? If you drop it, you will see that no water is coming out. Okay, and I want you to explain this phenomena. When the session has ended, you explain this phenomena in the chat box, okay, or in the comment section. Do you get this? Okay, you can do this experiment at home. Take a plastic water bottle, punch holes, put water, water will be coming out, but you drop it. While it is going down, you will see that no water comes out. I want you to explain this phenomena. Okay? Alright. Swastika is saying a pseudo force in itself doesn't exist, so there is nobody which experiences reaction of pseudo force. Yes, absolutely. No object is applying the pseudo force. The pseudo force is just a mathematical technique. It's just a mathematical manipulation. Alright, perfect, clear. Hai? So you also understand what is effective gravity, and you can find out the normal force exerted or the apparent weight of this person from this frame. From this frame, if you are doing it, you will have to apply a pseudo force. Correct? Ab in the same situation, if it is going down, okay, what will happen? फटाफट मेरे को बताओ G effective क्या होगा? What will be the reading of the normal force and what will be G effective? फटाफट मेरे को बताओ तो. ठीक है, I don't have to solve this. You are smart enough to understand this. है कि नहीं? So I am going to obviously solve it from the non-inertial frame. Now when I am solving it from the non-inertial frame, the lift is going downwards, so the pseudo force is going to act upwards, and what will be the force? The pseudo force is going to be upwards and m into a. From this frame, what do we see? From this frame we see that the object is at rest, so n will be equal to ma, sorry, n plus ma will be equal to mg, so n will be equal to mg minus a. So what is the effective gravity? The effective gravity we can say is g minus a. Is that correct? Okay. Jaya is asking Super 60 भी करो. What is Super 60, Jaya? I don't know what is Super 60. जी मोहम्मद is sir बार बार स्वास्तिका से ही पूछते हो हम नहीं है क्या? Okay, जी मोहम्मद. Swastika had asked me a question. That is why I was answering Swastika. If you ask me a question, I am going to answer it to you. Okay? चलो. तो effective gravity क्या हो जाएगी? It will become G minus A. Now just think about it. If the elevator is going down with an acceleration g, what will happen? Can someone tell me? If the elevator is going down with an acceleration g, ठीक है? ऐसा होना नहीं चाहिए. Suppose you are in an elevator, ठीक है? This is just a thought experiment. I don't want this to happen to you. Okay? You are in an elevator and the cable breaks. The cable which supports the elevator, that breaks. So in that case, the elevator is going to go down with what acceleration? It is going to go down with acceleration g. Okay? So the normal force will become what? The normal force is going to become 0. And this is the meaning of weightlessness. Is that correct? This is the meaning of weightlessness. Because how do we perceive weight? We perceive weight when something is pushing us. Okay? Something, the floor or the side of the wall or anything is applying a force on us. But in that case, there is no force being applied on us. So what will we feel? We'll feel weightless. Okay? Are we actually weightless? No. Obviously, we will have weight. But that is the apparent feeling. That is a feeling of falling down. And that's a very scary feeling. Okay? So if you want to do, there are rides, okay, which take you straight down. Okay? There are rides and they make you feel weightless. Okay? Or if you are a bit adventurous, you can do bungee jumping and feel that weightlessness. Okay? I have done that bungee jumping, and so once I have done bungee jumping, and that was the most scary feeling I have ever got. Okay? So when you fall down, you're like, your heart is pumping. Okay? Your heart is pumping. You feel a force on your chest. Okay? You feel a force on your chest. And it's a very uncomfortable feeling for most of the people, but obviously it's very thrilling. Okay, so if you want to experience that weightlessness, you can do bungee jumping. Okay, it's fun. It's actually fun. Chalo, anyway, yes, in a roller coaster also that happens. Okay, and if you're going down on a water slide, okay, in water parks, if you're going down that slide, you're accelerating, you feel that weightlessness as well. Okay. It's a very thrilling experience, but for some people, it's not very comfortable. Some people throw up. They're not used to this, but it's up to you. Try it and see how it feels for you. Okay? Chalo. स्वास्तिका बोल रही है नीचे पहुंचने से पहले शक्तिमान बचा लेगा, हम बच जाएंगे और फिजिक्स का प्रैक्टिकल भी हो जाएगा. अब शक्तिमान पे इतना भरोसा अगर है स्वास्तिका, then by all means go for it. But Shaktiman is also a pseudo character. Okay, he is a pseudo character. He is not a real character which is going to come and save you. ठीक है? तो physics पे ज़्यादा भरोसा रखो, शक्तिमान पे नहीं. All right, चलो. Now, because of this effective gravity, a lot of things can be affected. ठीक है? मान लो कि we have a pendulum which is inside an elevator. Now, I want you to tell me that if I displace, the elevator is going up with an acceleration A. And if I displace it a little bit, it is going to oscillate, and for small oscillations, it is going to perform SHM. ठीक है? तो चलो, can you tell me what is going to be the time period over here? कोई बता सकता है? Now you get the gist. ठीक है? You get the gist that what is effective gravity. And when you know what is effective gravity, you can manipulate your terms. ठीक है? तो जहां पे भी gravity आएगी, वहां पे effective gravity आ जाएगी. ठीक है? तो कौन सा आप असली में केबल काट दोगे? ठीक है, मैं नहीं काटूंगा, but you can try bungee jumping. ठीक है? That is very close to a free fall, or that is actually a free fall. ठीक है? For those 2-3 seconds, that is actually a free fall. ठीक है? So most people have already got the answer right. तो क्या हो जाएगा ये 2 pi root over L upon G plus A. ठीक है? I can solve this also. ठीक है? I can solve this also. So what I'm going to do is I'm going to get into this elevator frame. What are the forces? The forces are mg. The forces upward is going to be tension, and there is going to be a pseudo force in the downward direction. Okay. Now understand this. How to find G effective? In case of a pendulum, how to find G effective? ठीक है? When it is in its equilibrium position, the tension is going to be MA plus mg, and this will be equal to M into G effective. In any situation, when you have to find G effective, जब pendulum की बात कर रहे हैं, we have to find G effective. What will you do? You will calculate the tension and equate it to M into G effective when it is in equilibrium. ठीक है? किस situation की बात कर रहा हूं? Equilibrium situation की बात कर रहा हूं. ठीक है? That's how you're going to find G effective. So G effective in this case is going to be what? It is going to be G plus A. So जहां पे G हुआ करता था वहां पे क्या हो जाएगा? वहां पे G plus A हो जाएगा. Is that correct? Is that simple enough? ठीक है? So a lot of times you can apply this directly and it is going to save you a lot of time. And I'm going to show you one such problem also. But is this clear? How to find G effective? कैसे निकालना है G effective? Equilibrium में. ठीक है? Equilibrium में what is the tension? You have to equate it to M into G effective. Clear? चलो. In this case, फटाफट मेरे को बताओ टाइम पीरियड क्या हो जाएगा. Now this I don't have to calculate. You can tell me yourself. In this case, what will be the time period of the pendulum? सब चीज मैंने लिख दी है, बस आपको बताना है कि डिनोमिनेटर में क्या होगा. Not difficult at all. Yes, absolutely. It is going to be G minus A. क्योंकि इस केस में क्या हो जाएगा? T will be equal to mg minus ma. And we are going to equate it to M into G effective. Absolutely. Perfect. ठीक है. चलो. We have an Atwood machine. Now tell me what is the acceleration from the lift frame. Okay. I'm asking you what is the acceleration from the lift frame. With respect to the elevator, I have installed a camera inside the elevator and you need to tell me what is the acceleration of the blocks in the lift frame. Do I need to do calculations? या direct हो जाएगा? सोच के बताओ. Someone is saying G plus A, someone is saying G minus A. सोच के बताओ. दोनों ब्लॉक का बाबा. From the elevator frame, both the blocks will have the same acceleration, na? I'm talking about the elevator frame. From the elevator frame, what will be the acceleration of the blocks? Do I need to calculate this? या थोड़ा improvise करके, थोड़ा दिमाग लगा के directly answer निकाल सकते हैं? Tell me. सोचो what is the effect when I'm observing it from the elevator frame? What is the effect it is going to cause? सोच के बताओ. It's very simple. G की जगह G plus A आ जाएगा. Very good स्वास्तिका. ठीक है. So देखो, Rishit is saying in the lift frame it will be Atwood machine which is effective G as G plus A. Perfect answer. एकदम perfect answer. Well done. एकदम perfect answer. ठीक है. So on this block there is M2G for sure. There is M2G acting, but the pseudo force is also going to act on this. So this is going to be M2G plus M2A. So the net downward force on this block in this frame will be M2G plus M2A, and on this block in this frame will be M1G plus M1A. So what do we observe? The force used to be M2G, but now the force has become M2G plus A. The force here has become M1G plus A. So obviously what is the thing that is changing? Instead of G, now the effective gravity is G plus A. So we can say that the acceleration of M2 will be the same as acceleration of M1, and mind you, in elevator frame. ये मत बोल देना कि acceleration इसका ground frame में ये होगा. In elevator frame, be very careful. I am observing things from the elevator, and whatever answer I am going to get for the acceleration, it is going to be from the elevator frame. इसमें confuse मत हो जाना कि ये ground frame से होगा. Ground frame से निकालने के लिए आपको relative acceleration का यूज करना पड़ेगा. ठीक है? यू विल हैव टू यूज रिलेटिव एक्सेलरेशन. Is that correct? Whatever I'm calculating from this frame, okay, the acceleration would be from this frame. Is this correct? Is this clear? Is this absolutely clear? तो ये कितना हो जाएगा? ये तो अपने को पता ही है. क्या हो जाता है ये हो जाता है एक्सेलरेटर माइनस डिसेलरेटर divided by mass of the accelerator plus mass of the decelerator. Correct? तो अपना आंसर ये आ जाएगा. Okay? In the same situation, if it was going down, तो effective gravity कितनी हो जाएगी? G minus A हो जाएगी. ठीक है? So I don't need to explain that. Tension कितना हो जाएगा? Tension in the string. What will be the tension in the string? Can anyone tell me? Can anyone directly tell me what will be the tension in the string? सोच के बताओ. ये है अपना tension. What will be the tension in the string? अब आपको आइडिया लग गया है बेसिकली क्या करना है. तो टेंशन इन द स्ट्रिंग भी आप मेरे को डायरेक्टली बता सकते हो कि नहीं? फटाफट बताओ. What will be the tension in the string? चलो बताओ, फटाफट बताओ. What will be the tension in the string? टेंशन क्या होता अगर ये हम एक्सेलरेटेड फ्रेम से नहीं देख रहे होते? तो टेंशन क्या होता? टेंशन होता 2m1 m2 अपॉन m1 प्लस m2 इंटू जी. बट अब क्या हो गया है? अब g की जगह क्या गया है? g प्लस a. So this will be the tension. Do you agree? The tension will be this. The effective gravity has changed. And if the effective gravity has changed, wherever you have G, you're going to replace that by the effective gravity. भले वो G plus A हो या G minus A हो, that will depend on the situation. Yes, Rishit, you are absolutely right. Perfect answer. Absolutely perfect. ठीक है? चलो. Next, अभी तक हम लोग सिर्फ vertical acceleration की बात कर रहे थे. Now let's say we have a pendulum in the truck, and this truck is accelerating with an acceleration A. Now in this case I have to find out what is the time period of this pendulum. ठीक है? I have to find out what is the time period of this pendulum. Now एक बात तो पक्की है, will the string remain vertical? If this is accelerating with A, is the string going to be vertical? ठीक है? Now this is something we have seen in our car when we are driving a car. ठीक है? तो कुछ लोग बहुत चीजें लटकाते हैं ना. ठीक है? They hang something. कोई माला लटकाता है, कोई soft toy लटकाता है, but some people hang something in their car. ठीक है? So when you are accelerating, when you are not going with constant velocity, when you are accelerating, so you can see that whatever thing that you have that is hanging over there, that is going to tilt. ठीक है? That is going to tilt. और किधर टिल्ट करेगा? ये तो अपना कॉमन एक्सपीरियंस है कि इट इज गोइंग टू टिल्ट इन द ऑपोजिट डायरेक्शन. इज दैट करेक्ट? इट इज गोइंग टू टिल्ट इन द ऑपोजिट डायरेक्शन. ठीक है? नाउ दिस इज गोइंग टू बी इट्स मीन पोजिशन. दिस इज गोइंग टू बी इट्स इक्विलिब्रियम पोजिशन. And from this equilibrium position, if we displace it slightly, it is going to perform SHM. Is that correct? ठीक है? Now what are the forces that are going to act? The forces acting would be mg downwards. There is going to be tension. These are the real forces, but I am applying this. I am observing this from which frame? I am observing this from which frame? I am observing this from the frame of the truck. Which means that I'll have to apply a pseudo force, and the pseudo force is going to be like this. Okay. Now in the elevator frame, when this bob or when this pendulum is in equilibrium, all the forces will get cancelled. Do you agree? All the forces will get cancelled. Which means what? If we take a resultant of MA and MG, in which direction should it be? Can you tell me? If we take a resultant of MA and MG, what will be the direction in which the resultant would be? Okay, can you tell me? Now tension and MA and MG all together are going to give us what? It is going to give us zero force because right now it is in equilibrium. ठीक है, तो MA और MG का अगर हम लोग रिजल्टेंट ले लें तो फर्स्ट ऑफ ऑल द रिजल्टेंट इज गोइंग टू बी M under root of G square plus A square because both the forces are what? Both the forces are perpendicular to each other. And this force is going to be right opposite to the tension. It is going to be right opposite to the tension because MA and MG we can remove. We have taken the resultant. Now the resultant of T and MA and MG is what? 0. That is only possible when this force is opposite to the tension. So in this case, what is the value of tension we are going to get? The value of tension we are going to get is M into under root of G square plus A square. And what do we call it? What do we call it? We call it M into G effective because it is in equilibrium. The tension is equal to M into G effective. So what will be G effective? G effective is going to be the under root of G square plus A square. So what will be the time period? So because we have already used T, I am using TP for time period. ठीक है, कंफ्यूज मत होना. टेंशन के लिए T यूज कर लिया है तो टाइम पीरियड के लिए मैं TP यूज कर रहा हूं. ये कितना हो जाएगा? 2 pi under root of L upon G effective. And what is G effective? G effective is under root of G square plus A square. This will be the time period. ठीक है? Now if you try solving this from the ground frame, मेरा चैलेंज है कि आपको पसीना निकल जाएगा. ठीक है? If you try solving this from the ground frame, आपकी हालत खराब हो जाएगी. ठीक है? Because it is going to be very very tedious if you try to solve it from the ground frame. And that's where solving it in a non-inertial frame, solving it by applying a pseudo force helps. ठीक है? But you can try that. ठीक है? You can try that. You can try it solving from the ground frame. ठीक है? That will be a good practice for you. But that's what we are trying to do here. We want to save time. We want to solve questions efficiently. That is why we need to use pseudo force. Is that correct? चलो. So concept pseudo force का आपको बिल्कुल clear हो गया है. अगर clear हो गया है तो फटाफट give me a thumbs up, like this video, and you can subscribe if you have still not subscribed because otherwise you're going to miss the lectures, you're going to miss the notifications. Okay, so do that and we move ahead. Now is the time to solve some more questions. चलो, तो हमारे पास क्या है? So I'm not going to read out the entire question. I'm going to just tell you what the gist of the question is. It's a big question, and this question came in IIT JEE. ठीक है? JEE Advanced में आया था some year. I don't remember the year, but it did come in JEE Advanced. ठीक है? तो चलो. So we have a wire. It's a frictionless wire, and y is equal to kx square. ठीक है? Y is equal to kx square. So this wire is bent into the form of a parabola. ठीक है? Y is equal to kx square. Now there is a bead. ठीक है? There is a bead which has a mass m. So obviously you can see that the bead can slide through the wire. The bead can slide through the wire. Okay? Now this whole wire is moving towards the right with a constant acceleration a. ठीक है? So earlier the bead used to be here. ठीक है? When the wire was stationary, the bead would obviously be at the bottom. But when the wire started accelerating with a, then the bead obviously will not be at this position. The bead, by common sense, we can say the bead is going to be somewhere behind. Is that correct? The bead will go somewhere behind. ठीक है? But now the bead is not moving with respect to the wire. ठीक है? The bead can stay at rest with respect to the wire. So what do we need? At this position, we need how far is it from the y-axis, which means we need to tell its x coordinate. Is the question clear? Is the question absolutely clear? तो क्वेश्चन क्लियर है तो आप मुझे बताओ कि इसको सॉल्व कैसे करें. ठीक है? गिव मी सम हिंट हाउ टू सॉल्व इट. ठीक है? सबसे बड़ा हिंट क्या दिया हुआ है क्वेश्चन में? हमेशा सोचो कि इसमें मैथ लगेगा. यस, इसमें मैथ ऑब्वियसली लगेगा, बट सबसे बड़ा हिंट क्या दिया हुआ है? ठीक है? सबसे बड़ा हिंट दिया हुआ है कि दैट द बीड कैन स्टे एट रेस्ट विद रिस्पेक्ट टू द वायर. ठीक है? विद रिस्पेक्ट टू द वायर इट इज एट रेस्ट. ये सबसे बड़ा हिंट है. which means this is a hint to observe things from the wire. ठीक है, so what you can do is you can observe the bead from the frame of the wire. Yes, ये hint हमेशा याद रखना. This hint you should remember. ये हिंट हमेशा दिया रहेगा कि इस फ्रेम में दिस इज द एक्सेलरेशन और इस फ्रेम में दिस इज एट रेस्ट. करेक्ट? सो दैट इज इंडिकेशन इनफ that you can use pseudo force over here. That is going to be helpful. Okay, so let's start observing this from the wire frame. What are the actual forces? There is going to be an mg. This obviously is an actual force, and there is going to be a normal force as well. Correct? What will be the direction of the normal force? The normal force by definition is going to be normal to the curve. And what is normal to the curve? So first of all, let's make a tangent. बना दिया हमने tangent. So इस tangent के perpendicular होगा ना ये normal force. This normal force is going to be perpendicular to this tangent. ठीक है? And then what else? Now the real forces are done. Now we have to apply the pseudo force. Yes, the normal force is going to be perpendicular to the tangent, and Twinkle has given a very good explanation, or she has given a very good hint that the slope of the curve will be equal to tan theta. Is that correct? Absolutely. तो मैं थीटा ये एंगल ले रहा हूं. ठीक है? What I'm doing is I'm taking this angle theta. क्योंकि अपने को मैग्नीट्यूड से ही मतलब है ना, तो ज्यादा टेंशन नहीं लेने का. अपने को सिर्फ किससे मतलब है? मैग्नीट्यूड से मतलब है, तो ज्यादा टेंशन लेने की जरूरत नहीं है. ठीक है? Okay. So these are now all the forces, and in this frame, what do we know? In this frame we know that the bead is at rest, so the net force has to be equal to 0. So what we can do is we can resolve normal. MA and MG are already perpendicularly resolved. Now what we can do is we can resolve the normal force. तो ये एंगल क्या हो जाएगा? ये एंगल थीटा हो जाएगा कि नहीं? This angle will become theta. थोड़ा सा आप ज्योमेट्री यूज कर लो. I don't want to get into that. थोड़ा सा ज्योमेट्री यूज कर लो तो ये क्या हो जाएगा? और ये थीटा हो जाएगा. कौन सा थीटा हो जाएगा? Just let me check. Okay, if this is theta, then what is theta? If this is theta, then this is 90 minus theta, this is 90 minus theta, so this will be theta. ये theta हो जाएगा. I'm sorry, this will be theta. ठीक है? This will be theta. Okay, तो अब कर लें इसको resolve. तो ऊपर क्या आ जाएगा? ऊपर आ जाएगा n cos theta. इधर क्या आ जाएगा? n sin theta. And then you can forget about this. So n sin theta will be equal to what? It will be equal to ma. N cos theta will be equal to what? It will be equal to mg. ठीक है? Remember that this we are doing it from which frame? We are doing it from the frame of the wire. इस wire के frame में it is at rest. Ground frame में rest में है क्या? नहीं. ठीक है? तो क्या हो जाएगा? Tan theta will be equal to what? Tan theta will be equal to a upon g. Correct? Now how do we find tan theta? Y is equal to kx square. So dy by dx कितना हो जाएगा? dy by dx would be 2kx. ठीक है? And the magnitude of dy by dx is simply what? It's tan theta. We just have to deal with the magnitude. तो मैं प्लस माइनस साइन का टेंशन ले नहीं रहा हूं. तो tan theta की जगह हम क्या लिख सकते हैं? 2kx, and this is equal to a upon g. So what do we have to find out? We have to find out x, which will be a upon 2kg. ठीक है? All right, is this clear? Absolutely clear? ठीक है? Yes, all of you have got the answer absolutely right. ठीक है? So if this is clear, let's check the options. So you can see that option कौन सा? Option B will be the right option. ठीक है? X is in second quadrant, hence OT is negative. हाँ बाबा, नेगेटिव तो होगा ही. ठीक है? दिस x is also obviously going to be negative, but ये क्या पूछ रहा है? It is asking the distance. तो अपने को पॉजिटिव नेगेटिव से मतलब नहीं है. अगर कोऑर्डिनेट पूछता तो we would have said minus a upon 2 kg. बट ये डिस्टेंस पूछ रहा है तो नेगेटिव पॉजिटिव से मतलब नहीं है. तो सिर्फ मैं मैग्नीट्यूड के साथ काम कर रहा हूं. आई डोंट हैव टू वरी अबाउट द साइन. ठीक है? चलो, तो दिस इज क्लियर. लेट्स सॉल्व द नेक्स्ट क्वेश्चन. Again, it's a big question. बहुत सारे बहुत wordy question है. So I'll quickly give you what is the gist of the question. ठीक है? Diagram is very clear. There's a mass m और इसका length है L. And then there is a bead. Okay, this bead can slide over the string. Okay, this bead can slide over the string. Now this bead has a mass of small m. It can slide over the string. Now from this position it is released. Okay, from this position it is released, and it is given that capital M is greater than small m. And there is friction between the bead and the wire. Okay, there is a friction between the bead and the string. There is some friction. Now, it is seen that this bead is at the bottommost position with respect to the rod, and after some time the bead is at the topmost position with respect to the rod, and this takes time t. Okay, this takes time t. So what do we need to find out? We need to find out what is the frictional force between the ball and the thread. Is this clear? Is the question clear? तो ये question Irodov का है. ठीक है, it's a very famous question from Irodov. It's not very difficult. ठीक है, अगर आप pseudo force का concept लगाओगे तो it will not be very difficult. ठीक है, if you have understood the concept. But it's a good question. It's a question certainly we should solve. ठीक है, इसमें एक दो थोड़ी समझाने वाली चीजें हैं which I will certainly do. But is the question clear? कोई problem है question में? चलो, तो अगर हम ग्राउंड फ्रेम से देखें तो क्या होगा? If we see from the ground frame, capital M is going to go down. ठीक है, capital M is going to go down faster than small m. Small m is also going to go down. Small m ऊपर नहीं जाएगा. ठीक है, और repeat the entire question. अरे बाप रे. चलो, so I'm showing you the question. So meanwhile I'm explaining it. You can read the question again. ठीक है, it's me. Is it fine? You can read the question. अब ये पूरा question repeat करना थोड़ा सा मुश्किल काम है. ठीक है. Now if you observe this from the ground frame, क्या होगा? This bead is also going to go down. Is that correct? Bead ऊपर नहीं जाएगा. Think about it. The bead is also going to go down. But capital M is going to go down faster. ठीक है, so एक time पे क्या होगा कि this capital M is going to overtake the bead. Do you get this? This is going to be the situation from the ground frame. Okay. Now you guys tell me that would it be a better idea to solve it from the ground frame, or would it be a better idea to solve it from the frame of M, and why? ठीक है, if you can answer this question, concept clear हो जाएगा, उसके बाद सिर्फ calculation है. So I want this answer. Would it be a better idea to solve it from the ground frame, or would it be a better idea to solve it from the frame of M? ठीक है, and why? Obviously I need to know the reason as well. Dhruv is saying frame of capital M. Dhruv बताओ क्यों? What gives you the hint? ठीक है, अब ये मेरे को बोलना मत कि हम लोग pseudo force पढ़ रहे हैं. So obviously pseudo force अगर पढ़ रहे हैं तो pseudo force लगाएंगे ही. This question will be solved using pseudo force. ये आंसर मत देना. Suppose you don't know that we are studying pseudo force. ठीक है, in an examination it is not given that what concept the question is based on. ठीक है, so don't give me that answer. Give me the answer कि what is the hint in the question? Frame of M, because sir M is at rest with respect to the observer. ना बाबा, M is not at rest. M क्यों rest पे होगा? ठीक है, M तो नीचे आएगा. सर उससे सीधे हम acceleration opposite कर सकते हैं. ठीक है, चलो. The biggest hint is this statement. If t seconds after the beginning of the motion, the ball got opposite to the other end of the rod length equals L. ठीक है, नहीं, it's me. There is no equilibrium over here. ठीक है, equilibrium यहाँ पे नहीं है. Both the objects are accelerating. But the biggest hint is this. In t seconds after the beginning of the motion, the ball goes opposite to the upper end of the rod. So मेरे को क्या दिया हुआ है? I have been given the relative displacement of the bead with respect to capital M. Is it not? Think about it. I have been given the relative displacement. Relative to capital M, the ball is going from the bottom end to the top end, which means that the relative displacement is nothing but L. Can you observe that? Can you observe that hint in the question? That the relative displacement is given. The displacement with respect to capital M is given. The time is given. Okay? So it will be a good idea to find the acceleration of small m with respect to capital M. Is it not? Won't it be a good idea to find the acceleration of small m with respect to capital M? ठीक है, उस केस में क्या हो जाएगा? उस केस में we can directly say that the relative displacement is equal to half into the relative acceleration into t square. Do you agree? Do you agree with this? ठीक है, this is the hint in the question. यहीं पे यही चीज कैच करनी है आपको, बाकी तो सब कैलकुलेशन है, बट यही चीज कैच करनी है कि नहीं? ये चीज समझ में आई कि मेरे को क्वेश्चन में दिया हुआ है रिलेटिव डिस्प्लेसमेंट, मेरे को गया हुआ है टाइम, तो अगर रिलेटिव एक्सेलरेशन निकाल लें तो मेरा काम हो जाएगा ना? डू यू एग्री विद दैट? एंड इफ यू हैव टू फाइंड द acceleration of small m with respect to capital M, then what is the idea behind that? You just sit on capital M. ठीक है, suppose you are massless, you sit on capital M, or basically you attach a camera on capital M and observe things from the frame of capital M. ठीक है, that is the hint in the question. Now after this it becomes very simple. So free body diagram पहले बना लेते हैं. इसके ऊपर mg एक्ट करेगा, ठीक है, इसके ऊपर भी mg एक्ट करेगा. ओके, ठीक है. Now let's assume that the acceleration of capital M is a naught. ठीक है, let's assume the acceleration of capital M is a naught. Now be very careful that in this case the acceleration of small m is not going to be a naught. ठीक है, this is not an Atwood machine. Is this correct? This is not an Atwood machine. So the acceleration would not be a naught. ठीक है, it will be some other acceleration. ठीक है. What are the other forces? बीड के ऊपर और क्या फोर्स एक्ट करेगा? बीड के ऊपर फ्रिक्शन एक्ट करेगा ना? What will be the direction of the friction? The direction of the friction is going to be F. The direction of friction is going to be F. ठीक है? Okay. Now tell me what will be the force on capital M. Is there going to be any other force on capital M? There's going to be tension for sure. ठीक है? So there is going to be a friction on small m, because it is going to slide down on the wire or the thread. So there is going to be a friction on upwards, and then there is going to be a tension on capital M. Do you agree with this also? Okay, we are still in the ground frame. We are just talking about the real forces. Now can you tell me what is the relationship between T and F? कोई ये मेरे को बता सकता है क्या कि T और F में क्या relationship है? Why friction is upwards? So ऋषित सोच के देखो कि there is a bead which is hanging through the thread. ठीक है? Now what will be, how will the bead go down? Sorry, how would the bead move? Bead कैसे move करेगा? Bead तो नीचे ही move करेगा ना? So if the bead is moving down, so what is actually going to happen? The bead is going to move down. Capital M is going to move down. So the thread कैसे move करेगा? Thread ऊपर move करेगा. Suppose capital M is moving down, तो thread कैसे move करेगा? Thread ऊपर move करेगा. And small m क्या होगा? Small m will move down. So relative to the thread, small m किधर जा रहा है? नीचे जा रहा है. Do you get that? Relative to the thread, small m किधर जा रहा है? नीचे जा रहा है. तो उसके ऊपर force किधर लगेगा? ऊपर लगेगा. ठीक है? All right. ठीक है. Now yes, Swastika is absolutely right. Oh, are you telling me or you are asking me, Swastika? I thought that T and F are same. Yes, T and F will be same. Yes, you are absolutely right. देखो, what is F? F is the friction applied by the string on the mass. Do you agree with that? What is this friction? Who is applying this friction? The friction is the force applied by the thread on the mass. And the force applied by the thread is called what? It is called tension itself. So the tension and the friction are the same in this case. Whatever is the friction, will be the tension in the string. Do you get this? Is this clear? तो यहां पे भी क्या लगेगा, यहां पे भी फ्रिक्शन लगेगा. आई बात समझ में? So this is going to be friction. Is that correct? Perfect. Any problem here? So tension और friction अलग अलग नहीं होंगे इस केस में. The force applied by the string on small m is friction, and since it is the force applied by the string on an object, it is tension as well. And because the pulley is आपका ideal pulley है and the string is massless, so friction क्या लगेगा, जो tension लग रहा था capital M पे वो friction ही होगा. Is that correct? Okay. Now first I am going to write the equation for capital M. For capital M, the equation would be mg minus friction would be capital M into A naught. Do you agree? mg minus F will be equal to capital M into A naught. ठीक है? This I have written from the ground frame. Do you agree? This I have written from the ground frame. Because obviously I have to observe capital M from the ground frame. If I observe capital M from capital M, I'm not going to get any equation. It is going to be at rest. ठीक है? चलो. Now what I'm going to do is, now I'm going to put a camera on capital M. Now capital M has an acceleration downwards, correct? Capital M has an acceleration downwards, which means on small m, when I'm applying the pseudo force would be upwards and it is going to be MA naught. Is that correct? Now I'm observing small m from capital M. Do you agree with that? I'm observing small m from capital M. ठीक है? Is this correct? And with respect to capital M, what will be the acceleration of small m? Let us assume A. ठीक है? With respect to capital M, small m का displacement किधर होगा? ऊपर होगा ना? So I'm assuming the acceleration of small m with respect to capital M as A. And now I'm going to write an equation with respect to capital M. Now I'm going to write an equation in the frame of capital M. So I've done all my job. On small m, I have written all the real forces. I have written the pseudo force also, and I have assumed an acceleration also. This acceleration will be from what frame? It will be from the frame of capital M. Do you agree? Okay. So what should we write? We should write that F plus MA naught is going minus mg will be equal to small m into A. Which frame? Capital M frame. Is that correct? ठीक है? तो ये दो equation आ गया. Do I already know what is the acceleration of small m with respect to capital M? ठीक है? Do I already know that? Yes, I already know that. Because if you observe it from capital M, the relative displacement is L. The relative displacement is L. This will be equal to half into the relative acceleration A into t square. So from here what do we get? We get A is equal to 2L divided by t square. And we can plug it in over here. ठीक है? So now what we can write? So if this is clear, I'm going to go to the next slide and I'm going to write down the equations and solve it. So mg minus f कितना हो जाएगा? mg minus f is equal to m into a naught. ठीक है? और ये बन जाएगा f plus ma naught minus mg is equal to m into 2l upon t square. f plus ma naught minus mg will be equal to m into 2l by t square. So this is equation number 1. This is equation number 2. Let me check this equation once. Yes. ठीक है? Is this clear? Now what do we need to eliminate? We need to eliminate a naught. Correct? है कि नहीं? We need to eliminate a naught. ठीक है? तो simply let's eliminate a naught. We need friction. So let's eliminate a naught. तो a naught क्या हो जाएगा? G minus f upon capital M. From equation 1, this is a naught. This will be equal to what? This will be equal to G plus 2L upon T square minus F divided by M. ठीक है? So this G and this G is gone. Let's take it on the other side. So this will be F 1 by M minus 1 upon capital M is equal to 2L by T square. And then this is going to become capital M minus small m divided by small m capital M into F is equal to 2L by T square. So finally we are going to get F is equal to capital M small m 2L divided by capital M minus small m into T square. ठीक है? Yes. Is this clear? Is the question absolutely clear? If the question is absolutely clear, quickly give me a thumbs up. Quickly give me a yes so that I know it's clear and we can proceed to another very good question. हाँ, तो Rishit बोल रहा है so friction changes with time here. No Rishit, this T is a constant. The time it takes for this ball to cross this capital M, the time it takes for the bead to cross capital M is a constant. It is something which is recorded. So it is a constant. आई बात समझ में? It is not variable. Friction in this case is not going to be variable. The T given here is a constant. This is an actual recorded time. Is this clear? ठीक है? चलो, perfect. So in this case, friction is going to be a constant. चलो तो फटाफट क्या करते हैं? एक और बहुत अच्छा क्वेश्चन सॉल्व करते हैं. ठीक है? थोड़ा सा कॉम्प्लिकेटेड है, लेकिन जब कॉन्सेप्ट अपने को क्लियर हो जाता है तो क्या ही कॉम्प्लिकेटेड है ना? तो इसको भी हम बड़े आराम से सॉल्व कर लेंगे. ओके, तो दिख रहा है सिचुएशन. देयर इज स्मॉल m, देयर इज स्मॉल m प्राइम and they are attached by a pulley and there is capital M and a force F is acting on the wedge. ठीक है? We have to find the value of F. कंडीशन क्या है? ध्यान से सुनो कंडीशन क्या है. If a force F acts on the wedge of the blocks, do not slide relative to the wedge. With respect to capital M and capital M, small m is already moving upwards. Why will friction act upwards? Good question, Swastika. ठीक है. Swastika is a very good question. क्या question है? In the previous problem. Now, A is, so with respect to capital M, this bead is moving upwards. ठीक है? It has an acceleration A upwards. It is moving upwards. So Swastika is asking why friction is acting upwards. That's a very good question. Can anyone answer this? Can anyone answer this? ठीक है? That's a very legit question. That's a very good question. तो अपने को दिख रहा है ना कि from the frame of capital M, small m is moving upwards. So why the friction is acting upwards? Friction should act opposite, isn't it? Can anyone explain this? कोई explain कर सकता है क्या? Any ideas? Any thoughts? चलो, स्वास्तिका समझो इस बात को. जो फ्रिक्शन है, it is acting between capital M और small m. मेरे को ये बताओ, फ्रिक्शन कैपिटल M स्मॉल m के बीच में लग रहा है क्या? फ्रिक्शन किन दो ऑब्जेक्ट्स के बीच में लग रहा है? क्या फ्रिक्शन कैपिटल M और स्मॉल m के बीच में लग रहा है? नहीं. फ्रिक्शन किसके बीच में लग रहा है? फ्रिक्शन स्मॉल m और थ्रेड के बीच में लग रहा है. आ रही है बात समझ में? Friction is acting between small m and the thread. So if friction is acting between small m and the thread, then the relative motion of small m and thread has to be observed. ठीक है? तो सोचो, thread किधर जा रहा है? अब देखो, small m किधर जाएगा? Small m के ऊपर mg किधर एक्ट करेगा? नीचे एक्ट करेगा. तो small m किधर जाएगा? Small m नीचे जाएगा. So small m is going to go downwards. Now as capital M goes downwards, the thread is going to move upwards. So relative to the thread, small m किधर जा रहा है? Small m तो नीचे जा रहा है ना? Relative to the thread, practically सोचो इस सिचुएशन को. Small m क्या हो रहा है? Small m नीचे स्लाइड कर रहा है. It's just that capital M is going to slide faster. Small m is going down, but capital M is going to go down faster. ठीक है? बस यही हो रहा है. तो थ्रेड किधर जा रहा है? थ्रेड तो ऊपर जा रहा है ना. और बीड किधर जा रहा है? बीड नीचे जा रहा है ना. तो विथ रिस्पेक्ट टू द थ्रेड, हाउ इज द बीड मूविंग? विथ रिस्पेक्ट टू द थ्रेड, द बीड इज मूविंग डाउनवर्ड्स. इसीलिए उसके ऊपर फ्रिक्शन किधर लगा? उसके ऊपर फ्रिक्शन लगा अपवर्ड्स. इज दिस क्लियर? सो वी डोंट हैव टू सी द रिलेटिव मोशन ऑफ कैपिटल M एंड स्मॉल m फॉर फ्रिक्शन. Friction is acting between the thread and small m. So we have to see the relative motion of small m with respect to the thread. Thread के respect में तो किधर जा रहा है? नीचे ही जा रहा है ना? Is this clear, Swastika, now? Chalo. Now let's get back to this question. And what is in this question? What is the important thing in this question? Okay? The very important statement here is the blocks do not slide relative to the wedge. The blocks do not slide relative to the wedge, which gives us a big hint. What is that big hint? Can you tell me? The blocks do not slide with respect to capital M. It is a big hint. What is this hint? Can anyone explain that to me? What is this hint? Solve with respect to capital M. Absolutely. ठीक है, तो ये क्वेश्चन में दिया हुआ है कि कैपिटल एम के रिस्पेक्ट में स्मॉल एम और एम प्राइम मूव नहीं कर रहे हैं. ठीक है, सो इट्स अ ग्रेट आइडिया टू सिंपली जंप ऑन कैपिटल एम एंड ऑब्जर्व थिंग्स फ्रॉम कैपिटल एम. एंड इफ यू ऑब्जर्व थिंग्स फ्रॉम कैपिटल एम, क्या करना पड़ेगा? सूडो फोर्स लगाना पड़ेगा, बिकॉज कैपिटल एम विल बी एक्सेलरेटेड. ठीक है, तो आपको ये चीज बहुत आराम से समझ में आ गई. ठीक है, फर्स्ट ऑफ ऑल करेक्ट, यस एब्सोल्युटली. तो अगर अपने को सूडो फोर्स लगाना है, अब समझो इस बात को, अगर सूडो फोर्स अपने को लगाना है तो मेरे को कैपिटल एम का एक्सेलरेशन चाहिए ना. ठीक है, तो कैपिटल एम का एक्सेलरेशन तो मुझे निकालना पड़ेगा. If I have to sit on capital M, I need to know the acceleration of capital M, which means I need to find out what is the acceleration of capital M. ठीक है, और ये पहला क्वेश्चन ही है, find the acceleration of the wedge. Okay. अब मेरे को ये बताओ कि स्मॉल m, m प्राइम और कैपिटल M साथ में जा रहा है कि नहीं. Can we assume all the three masses to be one system? Yes or no? Question बहुत सिंपल है. Can we assume small m, m prime and capital M to be one single system? Can we assume that or not? Can we assume that? कर सकते हैं assume या नहीं कर सकते हैं? And why? सोच के देखो. Both the blocks have no relative motion with respect to capital M. यानी कि both the blocks are going along with capital M. Is that correct? So capital M, small m and m prime all are going एक साथ. अगर एक साथ जा रहे हैं with the same acceleration, then obviously we can assume them to be one system. So we can assume all of these three blocks are going to have an acceleration A in the forward direction. And in this case, what will happen? Just assume this to be a black box. What is the external horizontal force? The external horizontal force is F. Any force between these objects is an internal force. I don't need to worry about the internal force. Correct? The only external force in the horizontal direction is F. The combined mass is m plus m prime plus capital M. So acceleration is going to be F divided by capital M plus small m plus m prime, and we are sorted. Correct? Yes, absolutely. You have got this absolutely correct. ठीक है, अब नेक्स्ट चीज अपने को क्या निकालनी है? नेक्स्ट चीज अपने को निकालनी है एक्सेलरेशन ऑफ द वेज. तो निकाल लिया हमने, और क्या निकालना है हमें? हमको वैल्यू ऑफ एफ निकालना है. ठीक है, वैल्यू ऑफ एफ. वी नीड टू फाइंड आउट व्हाट इज द वैल्यू ऑफ एफ. दिस इज ओनली बिकॉज ब्लॉक्स आर नॉट मूविंग विद रिस्पेक्ट टू वेज. एब्सोल्युटली स्वास्तिका, दैट इज द रीजन. ठीक है, okay, अब what do we have to find out? We have to find out the value of f. Is that correct? ठीक है, what is the value of f? The value of f is such that small m and m prime are not moving with respect to capital M. ठीक है, तो क्या करते हैं? कैपिटल M पे बैठ जाते हैं. ठीक है, now we are sitting on capital M, which means we'll have to look at the real forces and we'll have to look at the pseudo forces as well. तो फटाफट फीड बॉडी डायग्राम बनाते हैं. m1 प्राइम g लग गया, टेंशन लग गया, टेंशन लग गया, mg लग गया, n लग गया, और क्या लगा? यहां से n प्राइम लगा, इसके ऊपर n प्राइम लगा, इसके ऊपर n लगा, इसके ऊपर कैपिटल mg लगा, इसके ऊपर n डबल प्राइम लगा. ठीक है, you see that I am drawing the free body diagram, but a lot of these forces would not be relevant क्योंकि वर्टिकल फोर्सेस जनरली बैलेंस हो जाएंगे. ठीक है, ये सब लग गया. अब इसके अलावा क्या हुआ? ठीक है, इसके अलावा क्या हुआ, इसके अलावा अपने को सूडो फोर्स लगाना पड़ेगा ना बाबा, ये ए एक्सेलरेशन है, अब कैपिटल एम पे बैठ गए, तो व्हाट वी कैन डू इज लेट्स ऑब्जर्व स्मॉल एम, इफ वी हैव टू ऑब्जर्व स्मॉल एम, इसके ऊपर एम ए ऐसे लगाना पड़ेगा, एंड इफ वी हैव टू ऑब्जर्व एम प्राइम, इसके ऊपर एम ए ऐसा लगाना पड़ेगा, ठीक है, इज दिस करेक्ट? तो ये फ्री बॉडी डायग्राम हो गया एम प्राइम का, और ये फ्री बॉडी डायग्राम हो गया एम का, ठीक है, करेक्ट? लगा दिया हमने सूडो फोर्स। अब तो बहुत क्लियरली बहुत सारी चीजें दिख जा रही हैं, ठीक है, अब वेरी क्लियरली वी कैन सी अ लॉट ऑफ थिंग्स। नाउ दिस स्मॉल एम इज गोइंग टू बी एट रेस्ट विद रिस्पेक्ट टू कैपिटल एम, यानी कि ऑल द फोर्सेस हैव टू बी बैलेंस्ड, यानी कि यहां से टेंशन इक्वल टू एम ए आ गया ना, नंबर वन, खत्म इसकी कहानी। एन और एम जी तो बैलेंस हो ही जाएगा, ठीक है, टेंशन इक्वल टू एम ए आ गया ना, करेक्ट? नाउ दिस स्मॉल एम इज एट रेस्ट फ्रॉम विच फ्रेम, फ्रॉम कैपिटल एम। कैपिटल एम में फ्रेम से देखने के लिए मैंने सूडो फोर्स लगा दिया, तो आई हैव डन व्हाट इज रिक्वायर्ड। सूडो फोर्स लगाने के बाद हॉरिजॉन्टल डायरेक्शन में कोई एक्सेलरेशन नहीं होगा, सो टी विल बी इक्वल टू एम ए, ठीक है। अब एम प्राइम के बारे में सोचो, एम प्राइम के बारे में सोच के क्या समझ में आता है? एम प्राइम के बारे में अगर हम सोचें तो वर्टिकल फोर्सेस बैलेंस हो जाएंगे, ठीक है, सो वर्टिकल फोर्सेस कितने हो जाएंगे? टेंशन विल बी इक्वल टू एम प्राइम जी, दिस इज इक्वेशन नंबर 2, करेक्ट? यानी कि यहां से क्या समझ में आ गया, यहां से समझ में आ गया कि एम ए इज इक्वल टू एम प्राइम जी, एंड व्हाट इज ए इज इक्वल टू एम प्राइम अपॉन स्मॉल एम इंटू जी, और यही निकालना था अपने को, है कि नहीं? दिस इज व्हाट वी हैड टू फाइंड आउट, द एक्सेलरेशन, ठीक है। तो एक्सेलरेशन एफ के टर्म्स में वी कैन नॉट फाइंड आउट, करेक्ट? एफ तो वेरिएबल है, एफ भी निकालना है, सो फाइंड द एक्सेलरेशन ऑफ द वेज, दिस इज द एक्सेलरेशन ऑफ द वेज, एम प्राइम अपॉन एम इंटू जी। आई बात समझ में? यस, एब्सोल्युटली। अब अपने को क्या चाहिए? अब अपने को चाहिए दिस फोर्स एफ। नाउ दिस फोर्स एफ इज एक्टिंग ऑन व्हाट? दिस फोर्स एफ इज एक्टिंग ऑन कैपिटल एम, ठीक है, ओके। तो अब अपने को देखना पड़ेगा कि कैपिटल एम के ऊपर क्या क्या फोर्सेस हैं, ठीक है। लेट्स लुक एट द फोर्सेस ऑन कैपिटल एम। बट एक और चीज मेरे को समझ में आ रही है, क्या समझ में आ रही है? फॉर एम प्राइम, इफ वी लुक एट द हॉरिजॉन्टल फोर्सेस, देन एम प्राइम एंड एम ए इज गोइंग टू बी बैलेंस्ड, ठीक है, ये समझ में आ रहा है। इफ वी लुक एट द हॉरिजॉन्टल इक्विलिब्रियम ऑफ एम प्राइम, देन द नॉर्मल फोर्स एन प्राइम इज इक्वल टू व्हाट? इज इक्वल टू द सूडो फोर्स एम ए, यानी कि n prime is equal to ma is one more equation that we have found out, okay. Now we need to find out what is the force F, which means we have to look at capital M only. What are the forces acting on capital M? तो एक mg लग रहा है इसके ऊपर, यहां से n डबल प्राइम लग रहा है, इससे कितना लग रहा है? इससे n प्राइम लग रहा है। Now this pulley is part of capital M, so whatever is the force on the pulley will be the force on the block capital M. So these are the forces, and under these forces it is accelerating with A, ठीक है। So now what we can do is we can simply write the equation for the horizontal motion. So what is the forces in the horizontal motion? The forces in the horizontal are F minus T minus N prime is equal to capital M into A. और ये सारी चीज हम लोग निकाल चुके हैं, तो this is very simple. What is T? T is equal to mg, करेक्ट, यहां से हम लोग निकाल चुके हैं ऑलरेडी। T is equal to ma, this we have already found out. T is equal to ma, ठीक है, माइनस what is n prime? N prime is equal to oh, this is going to be m prime a, ठीक है। So n prime will be equal to m prime a. So from here we can substitute n prime by m prime a, and this is equal to m into a, ठीक है। So f कितना आ जाएगा? f आ जाएगा कैपिटल m प्लस स्मॉल m प्लस m prime into the acceleration, and what we can substitute for acceleration is, we have already figured that out, what is acceleration? m prime by m into g. तो ये आ गया आपका f. We can directly substitute the newly found value of A in the previous equation connecting F and A. Okay. Yes, Swastika, you are right. You are right. Yes, yes, you are absolutely right. ठीक है, इतना करने की जरूरत नहीं थी. You are absolutely right. ठीक है. We have already found out what is A, so वहां से directly F निकल गया. You are absolutely right. ठीक है, तो इतना करने की जरूरत नहीं थी. I agree. I could not see that. ठीक है, but very good that you saw that, and that's a great way to solve it. Okay, perfect. Anyway, चलो, but समझ में आ गया कि pseudo force कब यूज करना है, क्यों यूज करना है. That is the important thing. All right, is this clear? चलो तो फटाफट give me a thumbs up if this is clear, and this is a homework for you. Easy question है, but मैं आपको ये homework दे दे रहा हूँ. ठीक है, take a screenshot, and when you find your answer, you can put it in the chat. I'm sorry, you can put it in the comment section, and वहां से I'll respond. ठीक है, Rahul Pandey is saying 1 minute sir. Yes Rahul, tell me what do you want to ask. हाँ, you take a screenshot, no problem. ठीक है, चलो, all right. So that is it. I'm going to see you very soon in the next session. Till then, keep practicing, keep getting better, and remember, you guys are rankers. Thanks for watching.